Hello students, this is Dr. Asifulla, working as Associate Professor and Head in the Department of Mathematics in Vijaya Vittala Institute of Technology, which comes under Hennur Bagalur Road, Bangalore. Let us discuss today's topic, limit of a function using L'Hospital's rule. Now let us see type 3. In this type, we are going to see the functions whose limit will be of the form 0 by 0 to the power 0, infinity to the power 0, 1 to the power infinity. Suppose your function under the limit is of this form, which is of the form function to the power function, and suppose this limit is giving you to the 0 to the power 0 or infinity to the power 0 or 1 to the power infinity, then we cannot apply L'Hospital's rule for such forms. As we know, LH rule is applicable for only 0 by 0 or infinity by infinity. So few manipulations has to be done to this function so that it will be in the form of 0 by 0 or infinity by infinity. So very first step we have to do in such functions is taking log on both sides. What is the intention behind taking log here? Because we know log a to the power b is b log a. That means we can bring this power as a multiplier here. Yes, as we are saying taking log on both sides, we have applied log here as well as log here. Then by using the logarithmic property, this g of x will come as a multiplier here. Yes, we have got log k is equal to limit as x is tending to a, g of x into log of f of x. Now after simplification, suppose your answer is L, then how do we get k? Because initially we have denoted the limit as k, so we expect the answer for k. We don't want the answer of log k. So how do we get k? Applying antilog on both sides. If you apply antilog on both sides, the answer for k will be k is equal to e to the power L. E to the power L. That means if you take this log to this side, you can remember it as e to the power L. Whatever answer you get, it becomes in the power of e. That will be the answer for the given question. Now let us apply these steps in some problems. Evaluate the following limits. These are all the questions. Among these, let us discuss question number 4. Here are some more, and here are some more. You can try all of these. Yes, as I said, let us discuss question number 4, which is given as this. Let us call this limit as k and apply log on both sides because it looks like function to the power function. It is clearly visible, function to the power function. So in such cases, as I said, we need to apply log first on both sides. We are saying here applying log on both sides, and we have applied log on both sides here, as you can see. Now using the property of logarithms, it is of the form log a to the power b. Then this b will come as a multiplication here, b log a form. Yes, we have taken this here as a multiplication here, you can see, and we have written log of this as it is. Let us call this as equation number 1, and let us apply the limit and check whether we get finite answer after putting the log on both sides or not. Yes, we have applied the limit x as a. Wherever x is there, we have applied the limit a, you can see. Then this a and this a gets cancelled, and this a and this a gets cancelled. What we get is tan pi by 2 into log of 2 minus 1. 2 minus 1 is 1, that is log 1. We know that tan 90 degree is infinity and log 1 is 0. So we got infinity into 0 form. We got infinity into 0 form. Now let us consider equation number 1 back and rewrite this equation number 1 in the form which gives 0 by 0 or infinity by infinity now, because for this indeterminate form LH rule is not applicable again. So that's why we have taken equation number 1 again and rewrite this. We all know tan can be written as 1 by cot. So tan of pi x by 2a can be written as 1 by cot of pi x by 2a. Somehow we brought the function to the form function divided by function by rewriting tan in terms of cot. Now again let us substitute this limit and check we get finite quantity or not. Yes, we have put the limit x as a in the numerator and in the denominator here. You can see here and here we have put x as a. In the numerator a and a gets cancelled. In the denominator a and a gets cancelled. So what we get in the numerator and denominator, let us see. In the numerator we get log of 2 minus 1 divided by cot of pi by 2. What we have, log 1 divided by cot pi by 2. Log 1 by cot pi by 2. We all know log 1 value is 0 and cot pi by 2 value is also 0. So finally we got 0 by 0 form for which LH rule is applicable. L Hospital's rule is applicable. So let us apply L Hospital's rule to equation number 2. The equation number 2 is given by this, to which we have to apply LH rule now. As we all know, LH rule says differentiate numerator and denominator separately, then again apply the limit. Let us do that. Differentiation of log of 2 minus x by a gives first 1 divided by 2 minus x by a. Then again by using the chain rule, we have to differentiate this inside function. When we differentiate this 2, it goes to 0 because it is a constant, minus 1 by a. 1 by a is a constant we have taken as it is. and differentiation of x is 1, which we have not displayed here because 1 into 1 by a is 1 by a itself. Yes, we are done with the differentiation in the numerator. Let us differentiate denominator. In the denominator also we have function of a function. First differentiation will give minus cosecant square of pi x by 2a, or differentiation of cot is minus cosecant square. Now let us differentiate this inside function pi x by 2a. Here pi divided by 2a is a constant, we have to keep as it is, and differentiation of x is 1. Now let us rewrite these things in the next slide. Yes, we have rewritten. Now let us substitute the limit and check whether we get the finite quantity or not. Yes, we have put the limit x as a here and x as a here as well in the denominator. Now what all things gets cancelled here? A and a gets cancelled. Here as well a and a gets cancelled. What remains is these things. Here 1 divided by 2 minus 1 is 1. 1 by 1 is 1. So in the numerator what remains is minus 1 by a. Let us see what remains in the denominator now. In the denominator what we get is minus pi by 2a, minus pi by 2a, and the value of cosecant square pi by 2 will be 1. If you check in your trigonometric table, you will get 1 in the place of cosecant square pi by 2. Now let us take this denominator to the reciprocal. Yes, it becomes minus 2a by pi when you take it to the numerator as a reciprocal. You can see here we have taken. Now what all things will happen in the next step? Minus into minus become plus, and this a and this a gets cancelled. Your answer will be 2 by pi. Yes, this is something like L. We got L as we had discussed in the procedure. Now how do we get the value of k? K is equal to e to the power this answer, that is e to the power 2 by pi. So this completes our solution for the given problem.